Hey, this is a section 2.3 redux. The first one, if you may have seen, did not contain audio. That was unfortunate. So we're going to try this video again. This material should be mostly review for everyone in this class. We're just going to define what lines are and just make sure that we're on a common understanding of lines. So algebraically, we can define a line to be an equation of the form y equals mx plus b, where m is our slope, or sometimes known as rise over run. In the case, we say rise over run in the case where m can be thought of as a fraction, where the numerator is how much it rises in a unit step, and the run is how far over it goes in that same step. Our b is our y-intercept. And it's precisely the y-intercept because it's the value on the y-axis that the line takes on. We'll see an example right now. So we want to graph the line y equals 3x plus 2. The first thing we should do is draw a graph axis. And then make a few tick marks on it. So in this case, 3 is our slope, and 2 is our y-intercept. Our y-intercept tells us where to start graphing on our graph. Because the y-intercept is 2, we start at 2 on the y-axis. Our slope is 3, and 3 is the same as 3 over 1. So that says our rise is 3, so we're going to move up 3 units. 1, 2, 3, and then move across only 1 unit, just 1. And make a second point. We then connect those 2 points with the line through it. And that's our line of y equals 3x plus 2. We just identify the y-intercept, plot the y-intercept, and then use the slope to find another point on the graph. We can also have equations of vertical and horizontal lines. And we'll start with a graph for these. So we'll make our graph axis. We'll draw a nice blue horizontal line. And oh my God, that was a disaster. Just trying to make sure we get it over the tick mark at 3. So tick mark 3. And so we notice that no matter what we plug in for x, no matter what our x value is, our y value is always the same. It's always going to be y equals 3. It doesn't depend on x, so we don't need an x in the equation. So a horizontal line is something that looks like y equals 3. Of course, if we had y equals -2, we might be down here. And just as we can have horizontal lines, we can also have vertical lines. This is our vertical line at 2. And maybe pause the video and see if you can think about what the equation for this line would have to be. All right, so hopefully you came up with that it has to be x equals 2. Because no matter what y is, our x value is always 2. So it's independent of y. So our vertical line example is x equals 2. Sometimes if we have a line, we are also interested in finding a line parallel to it. So we could do that by first drawing a picture and then pulling out a concept that will let us see what the parallel line has to be. Draw a red line and then use a fancy multicolor to draw a parallel line. So remember, two lines are parallel if they never intersect. And we want to think, say, if this line has equation mx plus b, then this y-intercept right here is b. This line, it's parallel, so it's changed a little bit. But one thing hasn't changed and one thing has changed. So we've noticed that the y-intercept definitely changed. It's now a value that we'll call c. But as we can see from the picture, it has the same slope. So this might be a line mx plus c. So the same slope, the same m's, just different y-intercepts. So we can classify all parallel lines by just choosing a different y-intercept. That's the idea. Parallel lines have the same slope. And just as we can have parallel lines, we can also have perpendicular lines. And remember that two things are perpendicular if, when they meet, we get a right angle. In this lecture, we're not actually going to discuss how we truly show that this condition is true to be perpendicular. But it turns out that if the product of two line slopes is -1, then those lines have to be perpendicular. The reason why isn't hard. It just takes a fair amount of geometry that we don't want to do. So we'll start with drawing a graph. And we want to find the line perpendicular to 3x plus 5. So we'll say that that's 5, that's 1, and that up there is 8. So our line crosses through at 0, 5, and then we go up 3 and over 1. So through at 1, 8. And then we just draw the line through those 2 points. And we want to find the line that's perpendicular to it and passes through 1, 1. So we're first going to use our condition. Use condition that slopes multiply to -1. So we want to find what's that abbreviation? A line y equals mx plus b, and 1, 1 is on the line. So if 1, 1 is on the line, then we also have that 1 equals m times 1 plus b. And so now we're going to first use our condition that the slopes multiply to -1. That means that -1 equals m times the slope of the line we have, which is 3. And just a division says that m equals -1/3. So we have our slope. Now what we're going to do is take this m and plug it in to this equation. And then we'll be able to find b. We'll have that 1 equals -1/3 times 1 plus b, which tells us that b equals 4/3. Therefore, our line is y equals -1/3 x plus 4/3. And we can just hop into our graph and graph that point, that line. So that's at 1, we go over 1 and down, or that's at 4/3, we go just a little bit, and we'll get a line that looks like this. And if it was a better picture, if I was better at drawing, we'd be able to see that they're truly right angles. Maybe a good thing to do right now would be to go into Desmos and graph that. So we'll do that. I'll stop sharing. That'll be enough on the iPad notes for right now.